Toyota just made one of the boldest moves ever as their all-new way of thinking completely contrasts the entire automotive industry's idea of the future. Instead of going towards an all-electric future, Toyota decided to breathe new life into the world of internal combustion engines. According to their CEO, their all-new engine will disrupt the entire car industry and its current flow. However, this decision did not come out of nowhere. Toyota's insistence on keeping their internal combustion engine going has been one of their driving factors for quite some time. These engines and their notorious reliability are the things that kept Toyota at the top of its competition, and it is only logical for them to keep exploring and modernizing them so that they can maintain that gap. They truly outdid themselves with the final product. We are talking about a revolution that is greater than the hybrid revolution, instrumented once again by Toyota and its Prius. You can only imagine the sheer and unfathomable importance that this technology harnesses. So with that in mind, let us answer the question that you are currently asking yourselves, and that is, what is this all-new technology? The technology we are so absorbed and mesmerized by is Toyota's all-new hydrogen technology. And no, we are not talking about hydrogen electric vehicles such as the Toyota Mirai. Oh no, what Toyota is doing now is their all-new hydrogen combustion engine technology. CAVs such as the Mirai have a bit of a performance issue, and by that, we mean that they were severely underpowered, extremely overweight, and very mediocre in terms of daily usability. Even 10 years after their original inception, they are way too impractical to be useful. But what we cannot deny is the ecological component that comes with using hydrogen, seeing how it is the most abundant element in the world. Since it is also so completely eco-friendly, it is understandable why Toyota wanted and still wants to develop cars that use it. This is especially interesting now, in a time when lithium-ion batteries tend to stir up quite a lot of controversy in terms of how eco-friendly they are, seeing how lithium mining poisons both the soil and the water surrounding the mine. Furthermore, even with the continuous development of lithium-ion batteries, recharging them, as well as their range, simply leaves a lot to be desired. Now, combining the potency of regular internal combustion engines with the ecological component of hydrogen would effectively remove all issues of both technologies altogether. BMW already explored this technology in the late 90s and early 2000s, and it showed a lot of potential even back then. BMW's hydrogen-powered E38 and E65 7 Series V12 engines were proven to be quite reliable and had plenty of power, without being any less economical than the gasoline versions. However, hydrogen infrastructure back in the day was non-existent, which is why neither of the two moved out of the prototype phase. But thanks to Toyota's efforts with the Mirai, the network has grown quite a bit since then. As a result, Toyota, unlike BMW, now has actual backing to start making their own hydrogen combustion engine, which is exactly what the company is doing. With all of this in mind, it is time for us to peek into the specifics of the hydrogen combustion engine and explain what the similarities are to regular internal combustion engines. The biggest similarity between the two technologies is obviously the fact that they both rely on internal combustion. Also, gasoline engines tend to be exceptionally good hosts for modifications that would allow an overhaul and conversion to hydrogen. Most hydrogen power plants are designed this way, especially Toyota's. There are two engines that Toyota currently has in their portfolio, both of which are designed for different purposes. The more popular of the two is the 1.6 liters turbocharged, three-cylinder, yes, the same unit that is found in the GR Yaris and GR Corolla. The engines are so alike one another that despite the change of propellant, the hydrogen 1.6 sounds just as growly as its gasoline counterpart. Take a listen. The other power plant is Toyota's 5 liters V8, derived from the same unit used in the Lexus RCF. This engine, unlike the 1.6, which is planned to be used in sportier, smaller cars, is designed as a workhorse engine. Toyota's plan is to use this powerhouse of a unit with its pickup trucks, large SUVs, and even some large sedans and coupes. However, even with all these advancements, there is another technology that Toyota is developing as a basis for hydrogen cars, which is Toyota's new ammonia engine. Toyota has recently started exploring the possibility of using hydrogen and storing it safely by simply not separating it from the compound that it is a part of. Their extensive research has led them to the idea of using ammonia as a propellant. Despite water being the most obvious choice for a hydrogen container, extracting hydrogen from it is quite a nightmare, at least currently. On the other hand, storing hydrogen is also exceptionally problematic. As already mentioned, This is exactly where ammonia comes in. You see, ammonia, which consists of nitrogen and hydrogen, serves as the best middle ground for hydrogen's further development. This is because ammonia, unlike water, can combust, making it an actually viable fuel. Furthermore, since ammonia is combustible, and since hydrogen is one of the two parts of its composition, separating hydrogen is not required. This, therefore, eliminates the need for one of the most complex and most cost-ineffective parts of utilizing hydrogen as a propellant. Not to mention that by not separating hydrogen, you will also be eliminating the need to store it too. This means that another expensive part of the hydrogen future will be cut out of the equation entirely. Oh, and you can also say goodbye to heavy, large fuel tanks too, as ammonia is incomparably less problematic to store than hydrogen. Furthermore, ammonia is also extremely plentiful, seeing as it is the most plentiful alkaline gas in the atmosphere. This means that it is also exceptionally affordable for purchase, exceeding gasoline in terms of affordability, let alone hydrogen. Plus, ammonia is much stabler than hydrogen, which in turn results in it being noticeably safer too. Unlike hydrogen, which is very explosive, the only thing you should worry about with ammonia is not inhaling it. The storing process is otherwise identical to storing liquid petroleum gas, for example. Toyota is so on board with this idea that the company paired up with the Chinese automotive giant GAC to make their own ammonia-powered engine, and they recently did just that. The 2.0 liters R4 runs on liquid ammonia, and after extensive testing, the engine proved to be 10 times more eco-friendly than its gasoline counterpart. Sure, this is not truly zero emission. However, neither is going fully electric, as both making batteries as well as producing electricity for them is extremely polluting. Plus, ammonia engines are technically hydrogen engines with only a few differences, most of which can be summed up to the fuel injection system. As a result, they will also allow for parallel development of hydrogen as a sole propellant, making it a very future-proof and forward-thinking technology. Speaking of the future, it is time for us to ask the most important question, and that is hydrogen the future? Well, it is still too early to say. However, we do believe that hydrogen is shaping up to be the fuel of the future. You see, despite its current hardships, it is simply undeniable that hydrogen currently has the most potential out of all other means of powering vehicles. You see, despite its issues, hydrogen remains the only way of powering vehicles without any emissions. Not to mention that it can also, with the development of the infrastructure and technology that surrounds it, achieve an incredibly low, borderline non-existent price tag. Not to mention that the EV industry has been getting quite a lot of backlash in the past few years, as lithium-ion batteries keep being insufficient for real-world use while also being extremely polluting and expensive to produce. As a result, even 10 years after they became popular, EVs are still a thing of niche and luxury with exorbitant price tags and limited uses, which is exactly what hydrogen sets out to fix. Granted, we do not expect hydrogen to become popular imminently. However, Toyota's insistence on developing it and the currently prominent rise of synthetic fuels, as well as the drop in popularity for EVs, tells us that there is quite a lot of reason to believe that hydrogen is far from obsolete. Not to mention that the most ambitious projects in the world, such as Saudi Arabia's The Line, also account for hydrogen's potential and expect it to be the main power source for the entire city. Plus, with the development of other hydrogen-based technologies that are more user-friendly currently, such as ammonia engines, hydrogen will also passively increase in popularity, and its development will also be fueled indirectly. Overall, despite the myriad of problems that it is facing now, we expect that hydrogen will, in the next decade or two, rise to become one of the driving forces for humanity in general.